change isn't just an issue for future generations anymore, or for people or animals who live far away. It's already affecting us right here in the places where we live. And the more climate changes, the bigger the impacts we'll see. The Pacific Northwest has an incredibly diverse natural environment, from rocky coastlines to snow-capped volcanoes, and rainforests to dry inland valleys. When it comes to climate change, this region is one that some people have suggested people could actually move to as other parts of the U.S. become less habitable in the future. Yet even in the Pacific Northwest, climate change threatens the diversity and the resources that make this region so unique. And as the National Climate Assessment finds, those who are most at risk are communities that are already economically disadvantaged, or those that are most dependent on natural resources for their livelihoods, including many tribal nations. In 2015, the Pacific Northwest experienced a very unusual year. Unusual, that is, in terms of past years, but not unusual in that it was exactly the type of year we climate scientists expect to see more of in the future. It all started off with very warm conditions. Because of that, more of the winter precipitation fell as rain rather than snow, and the snow that did accumulate melted quickly. Snowpack hit a record low, leading to extreme water scarcity in the summer, which in turn led to record-breaking wildfires. The Okanagan Fire was the biggest and most destructive in the history of Washington state. It burned more than 500,000 acres. And that same year, over 1 million acres burned in a series of wildfires in Oregon. Since the 1950s, snowpack on April 1st, which is an indicator of the natural water storage available for the warm season, has declined by an average of about 25% across the Cascades, with some locations experiencing up to a 60% decrease. Peak runoff has also shifted to earlier in the year as the snowpack is melting earlier. In the future, snowpack is expected to continue to decline, and the risk of wildfire is expected to continue to increase due to warmer temperatures and earlier and less spring snowmelt. This is being exacerbated too by the northward spread of pests, like the mountain pine beetle, which can leave millions of acres of trees dead or dying in its wake. In addition to the destruction of homes and infrastructure, wildfires also affect the region's agriculture, its hydropower, and the quality of the air and drinking water. Warm conditions also affect iconic cold water fish species like trout and salmon. They become severely stressed in water temperatures over about 70 degrees Fahrenheit. The record warm temperatures in 2015 didn't just affect freshwater fish though, they even led to a large and harmful algae bloom that impacted the year's fish and shellfish yields off the coast. And it's not just about warming either. Ocean acidification poses an additional threat to the fisheries of the Pacific Northwest. Of course, the flip side is that there are also very wet years with heavy rainfall. There's El Niño-related winter storms that batter the coast. There's atmospheric rivers, which are also expected to get stronger under climate change. Atmospheric rivers are long, narrow streams of water that are really like rivers in the sky. They transport vast amounts of water thousands of miles across the Pacific to land. They currently account for about 30 to 40% of annual precipitation along the west coast of the U.S., and they're expected to get stronger and more frequent as warmer temperatures increase the levels of water vapor in the atmosphere. If you live in the Arctic, the evidence of a warming climate is all around you. Temperatures in Alaska and the Arctic are warming twice as fast on average as temperatures down here where the rest of us live. Why? It's thanks to what scientists call positive feedbacks, but what I think should really be called vicious cycles. Cycles that take human-induced warming and amplify it big time. As I discussed in our Global Weirding episode on the Arctic, these cycles include warming temperatures that are melting the reflective white ice and snow that covers much of the ground, replacing it with darker water and land, which absorbs more of the sun's energy, which in turn causes the region to warm faster. And that is literally just the tip of the iceberg, because what used to be permanently frozen ground in the Arctic is thawing. This releases the carbon and methane trapped in the permafrost from organic material that decayed a long time ago. These, of course, are heat-trapping gases, and so they trap even more heat. As you can see, vicious cycle really is the best term for it. So what impact is all of this having on Alaska? If you don't live there, you might think global warming's a good thing. After all, it's so cold, isn't it? But both the human and the natural systems in Alaska are perfectly adapted to the way that climate has been. And as the state warms, and the ground thaws, and the ice melts, the impacts are growing. Much of Alaska's infrastructure, from buildings to roads to oil pipelines, is built in what used to be permanently frozen ground. But as the permafrost thaws, infrastructure damages are estimated to range from about $100 to nearly $300 million per year. Many remote communities in the far north, often populated by Native Americans, are accessed solely by winter roads or rail lines, which they depend on to stockpile basic necessities, food, fuel, and building materials to help them make it through the cold, long nights. The winter road season is getting shorter, and this is isolating many of these communities. In 2018, the U.S. government announced that FEMA and Alaska's Division of Homeland Security and Emergency Management approved spending $1.7 million to buy the homes of approximately 1/8 of the population of only one of the most urgent of these villages, Newtok. But for other villages, it's already too late. In 2003, the U.S. Army Corps of Engineers found that most of the more than 200 Native American villages in Alaska were already being affected by flooding and erosion. By 2009, they'd identified 31 that were at imminent risk. In an attempt to postpone the inevitable, a corporation called Arctic Foundations has developed a technology called thermosiphon. It consists of narrow tubes that passively pull heat from the ground into the air, cooling the permafrost and hopefully extending its lifetime. Oil companies and towns are using these to help refreeze or prevent the thawing of the permafrost that's under or near key infrastructure, like buildings and wells and pipelines. Impacts on infrastructure are just the tip of the iceberg again, though. We haven't even mentioned the effect of warmer temperatures and retreating sea ice on traditional Inuit livelihoods and culture, the fact that it endangers iconic species like the polar bear, the rapid changes to unique and fragile ecosystems on land and in the ocean, including the northern migration of the tree line and increased risk of wildfire, and that Alaska is home to more than 25,000 glaciers that are losing an average of 75 billion tons of ice a year as they melt. These shrinking glaciers and thawing permafrost appear to be increasing the risk of landslides, avalanches, and even earthquakes in the region. When it comes to climate change, Alaska truly is on the front lines. If you live on an island in the Pacific or the Caribbean, then you're uniquely vulnerable. And not just you, but all the plants and animals in the ecosystems who share the island with you. When disaster strikes, whether in the form of a devastating tropical storm or sea level rise or increasingly warmer, drier conditions, if you live on an island, there's nowhere to go. Many islanders also live along the coasts, and that's where sea level rise and stronger storm surge and more powerful tropical cyclones or typhoons or hurricanes can put you directly in harm's way. Climate change isn't increasing the number of these tropical storms, but as we discussed in our Global Weirding episode on hurricanes, it is making them bigger and stronger. They're intensifying faster and they're moving more slowly on average so they can dump more rain on us. The 2017 hurricane season showed how devastating these storms are to the Caribbean. Hurricane Irma decimated St. John and the Virgin Islands and destroyed 95% of the homes on Barbuda, leaving it uninhabitable for months. Hurricane Maria was the worst disaster in recorded history to hit the islands of Puerto Rico and Dominica. It took nearly a year to restore power to everyone in Puerto Rico who'd lost it, and the death toll is estimated at over 3,000 people. But even without the effect of stronger storms, just taking into account sea level rise alone, the risks are still very serious. Hawaii estimates it will cost them at least $15 billion, which is more than 50 times the entire annual budget of the state's Department of Transportation, to raise or relocate basic roadways, bridges, and other infrastructure to preserve them from this slow motion risk. Islands are also very sensitive to drought. In both the Caribbean and the Pacific, freshwater resources are expected to decline over time. Why? Because average rainfall is expected to decrease, but also rising sea level increases the risk of contamination of freshwater coastal aquifers due to saltwater intrusion. In the Pacific, many low-lying islands are already seeing this happen. The ocean itself is very important to island communities and regions. Tourism and fishing industry depend on the resources available off the coast, and these are also being impacted by a changing climate. In Hawaii alone, it's estimated that coral reefs contribute nearly $500 million to the local economy every year. Warming ocean waters, increasing acidification, and the added risk of deoxygenization, all of these exacerbate existing problems of pollution, runoff, and unsustainable harvesting of resources. Coral reefs are one of the most important and the most sensitive ecosystems in the world. They're often called the nurseries of the ocean because over a quarter of all marine species spend at least some part of their life cycle in a coral reef. As the National Climate Assessment says, severe, repeated, or prolonged periods of high temperatures leading to extended coral bleaching can actually result in colony death. Widespread coral reef bleaching is already occurring frequently in both the Caribbean and the Pacific Oceans. Around the world, it's estimated that high temperature events that cause bleaching are now occurring on average once every 6 years, instead of once every 25 to 30 years as they did back in the 1980s. By mid-century, they could be an annual event. The bottom line is we care about a changing climate because it's loading the dice against us. It's taking many of our naturally occurring risks and our pre-existing vulnerabilities, and it's making them worse in ways that affect us directly here and now. I live in West Texas where the roads are long and straight. So straight that if you really wanted to, you could drive down the highway just looking in the rearview mirror. Until that is, you hit a curve in the road. If you are not looking up ahead, you'll miss the curve and boom, you're off the road. What does this have to do with climate? The same principle applies. The information that we use to plan for our future is crucial. If we're relying on historical climate averages to determine future risks, we'll end up far from where we want it to be, unprepared for intense rainfall, record heat waves, or rising seas up ahead. No matter where we live, we're on the curve today. And what can we do about it? We need to prepare, to build resilience to the risks that we can't avoid, and, as I discussed in many other Global Weirding episodes, to reduce our emissions of heat-trapping gases to avoid the risks that we can. The U.S. National Climate Assessment is one important resource that helps us look ahead down that road. Please check out nca2018.globalchange.gov for more valuable information on how climate is changing in the places where you live and what we can do to prepare. Thanks for watching Global Weirding. This episode was brought to you in part by Citizens Climate Lobby. If you have any questions about climate versus weather, let us know during one of our Facebook Live Q&As. And please be sure to check out globalweirdingseries.com for more episodes. See you next time.